Okay, I happen to have a chance to try out a relatively newly released Realsense D455, which is another stereo vision depth scanner from Intel. It has a longer baseline compared to its predecessor, D435. A longer baseline in stereo vision practically means further targeting distance or working distance for sensing, not necessarily any better in performance. So let's see how they do by different distances. We've got some objects representing some geometric primitives, stack boxes, cylinder, a BMO figure, a rounded box-shaped power bank, and they all have different reflectiveness of light on their surfaces. For RGB pictures, I believe it's not going to be a fair comparison since the two devices have different RGB field of view, resolutions, and different shutter types. Besides, who cares about Realsense image quality, right? So the first one up is a comparison in about half a meter. For all comparisons, by the way, I did ICP scan matching, so comparisons can be visualized overlapped to each other. You can see the measured distance to an object is roughly 450mm. In this close range, they look pretty much equally good to me. Like you can clearly see a partial cylinder here, and corners of boxes are recognizable. A slight difference that I noticed here is that D435 did a tiny bit better in capturing orthogonal corners of boxes. Other than that, they look pretty much the same to me, better than I expected for Realsense devices. Next up, I moved the stand further from the object. The distance to an object is roughly 750mm and 800mm to the wall back of the scene. From this distance, it's clear that both devices are failing to secure geometric primitives of objects. You can see the corners of boxes are sort of rounded, and that box with rounded corner is actually turning to a circular object in the data. As we take a closer look, they do produce noticeable different data from the same scene. While boxes and cylinder primitives are captured in equally sort of distorted forms, I figured there's a potentially significant difference on the wall back of the scene. Like you can see from the side view, the point cloud from D455 shows much more condensed points of the wall compared to that of D35. This can be an important factor when choosing which one to use on your system, because having a better set of plane points leads to a more robust plane segmentations, which is essential in many robotics systems. Okay, for the last comparison, I moved the camera even further, so distance to objects to be roughly 1.4 meter. From this distance, objects are now not even recognizable by human eyes on the data from both devices. I think it is safe to say that these devices are not designed for object recognition at this distance. Still, there's a very important information we can find out, and that is the plane feature. It's quite hard to explain all the advantages of successfully segmenting plane features in such a short video, so I'll just skip it for this video. So it seems pretty clear that the points of the wall from D55 form a lot closer to a plane compared to that of D35, which look like an ocean wave. Honestly, I was a little surprised that a stereoscopic Realsense device can be this good in capturing a plane feature. Anyhow, this difference in performance of securing plane feature gets greater as the distance from each devices get further. Especially D455 should perform better in longer range compared to D35 theoretically, since it has a longer baseline. I also thought maybe the post-processing of each data was done with different settings, but they found out to be identical. So for my final thought, when it comes to depth scanning, everything else aren't that different, but D455 surely outperforms in securing plane features and tends to possess less noise in longer distances like over 1 meter. Alright, that's about it. Thanks for watching, and I'll see you next time.